Welcome back, friends. This is the notes for 7.2. Multiplication and division with those rational expressions that we've been looking at. And so I want to remind you about the videos in the book. I want to remind you about doing the daily incentive points. There's a daily incentive for block 1 and also for block 2. And so I want to make sure that you're doing those. And then I've also posted the answers for you so that you can grade your own. In the answers is some code words that you'll need. And I will be sending you an email on Thursday, before Thursday, so that that you can answer those code words and email it back to me. It'll be due by Friday. And so I think I'm going to have it due Friday at noon. And anyway, so that'll all be in the email for you. Anyway, so here we go. How you multiply is you multiply the numerators together and you multiply the denominators together, and then you factor all of the pieces. And it doesn't really matter. You can factor all the pieces and then multiply them together, and that's what I usually like to do, I have to admit. And this is the order the book does it in, but it doesn't matter. And then you reduce the pieces that are exactly the same. They reduce to 1. So we've been practicing that. To divide means to multiply by the reciprocal. So how you divide is you rewrite it as a multiply, and then you follow the directions for multiplying. Smiley face, right? So we'll give a try to that. So on this one, I could push this together right up at front and multiply 8 times 14. But it's also okay for me to say that 8, now I'm going to factor 8, is 2 times 2 times 2. And x to the third is x times x times x. Because it was a monomial, I didn't start thinking, difference of squares and whatnot. Times, and then 14, that's 2 times 7. And y, 6 times. And if you're talking and writing y's, you'll lose count. Okay. And then in the denominator here, I have 7 and then 4 y's, y times y times y. These are all monomials. And then 16 is 2 times 2 times 2 times 2. And then xx. And then you can say, because this is a multiply, that this is just 1, this is a times, like that. If you like, just push it all together, one numerator together. Multiply the numerators together, and then you reduce out pieces that are exactly the same. So right here is 2 times 2 times 2. And I can reduce that with, right here, 2 times 2 times 2. And so if I was clever and was watching what I had there before I started factoring, I could have said, ooh, I can reduce out 8, right? And that would have worked as well. And then x squared, right, will reduce out. And so I'll reduce these out. When you reduce them out, 8 divided by 8 is 1. X squared divided by x squared is 1. I'm going to leave this x so that I can see it, because I didn't get it. It didn't reduce out, right? And then I have a 7 to reduce out here. And, this 2 will reduce out with this 2. Gosh, this is going to reduce down to hardly anything, right? And so I know I still have an x. And then 4 y's will reduce. I have 4 here, and I had, if you're saying, hey, didn't we do these in chapter 4, and didn't we use the quotient rule instead of writing them out? And the answer is, hey, you're right, we did. And so that would be another way of doing it when you have a monomial. So I just factored all the pieces just like I'm going to do with the binomials that are down below. But I definitely agree with you that we would, I don't know why I did that. And so this is going to be x times y squared. Then here we have a multiply, a divide, so we want to rewrite it as a multiply, so we multiply by the reciprocal. So this is 6x squared over 5y cubed times 11z squared over 2x squared times 10y to the 8 over 33z to the 5th. So if you don't want to write all of those things out because it's monomials, you can just kind of watch what's gonna reduce out, and you can kind of put it together, and that would be perfectly fine way of going. I'm just going to practice my, so I see I have a 2 down here, so I'm going to write the 6 as 2 times 3. I'm going to go ahead and leave the x squared as x squared because it's going to reduce with that one. On the 5y cubed, I'm going to write this 5y cubed because I see that it's going to reduce with the 10 there. The 11 z to the second is okay. 2x to the second is okay. The 10 I'm going to write as 2 times 5. And then the y's, I'm going to write these y's as y to the third times y to the fifth, just so that when I go to cancel them out, right, when they reduce out, 3 of them are going to reduce out and leave 5. There were 8 of them altogether. And I don't know, just kind of a way of going, just to kind of shorten my work over this one. And so just another way of looking at it. 3 times 11, and then that's z to the fifth, and I notice I have a z to the second, so I'm going to write z to the second times z to the third to make 5 of them all together. And so this 2 reduces with that 2. This x to the second reduces with this x to the second. This 11 reduces with that 11. I didn't see that 3 reduces with this 3. Anything in the top reduces with anything in the bottom, because you could say this is all one fraction. And then I have y to the, I have a 5 reducing with a 5 monomial. Y to the third monomial reducing with y to the third. And I thought there was some z's. Yeah, there they are. Z to the second and z to the second. And what that leaves, after all the dust clears there, is y to the fifth over z to the third. So there's our answer there. So I'm almost at the bottom of my paper, as I always kind of write down there. Now, these are more like what we're really kind of trying to look at here. Those were just to get the practice on the reducing and whatnot, but this is what we're really on about, is ones that have binomials and trinomials in them. And so, but what you do is you just factor all the pieces. So I want to factor y minus 1. Well, it doesn't factor, it's just y minus 1. And I want to factor y squared minus y minus 6. And I'm going to move this down a little bit so that I can have room to think about it right there. Y times y, right? It's a trinomial. And 2 times 3, and you guys agree, a minus and a plus. So I had the y minus 1 in the numerator. I like to put parentheses around it because it didn't factor. And then I'm going to have y plus 2, y minus 3. And then in the other numerator, I'm factoring that, and I'm going to kind of think here, I'm going to be a cheater here, y times y, just a place to write it, 5 times, oh, not 5 times 1, that doesn't make 6, 2 times 3 makes 6, but also adds to 5. So that's going to be y plus 2, y plus 3. And then this guy is a binomial, and you can factor these in any order you wanted. So if you wanted to factor the binomial first, you could have, and it's a difference of squares, y plus 1 times y minus 1. And then things will reduce. This is a times, so since this is a times, you can say all one line, and anything in the top will reduce with anything in the bottom. So as long as they're exactly the same, I don't know why I said with anything you want, no, y minus 1 and a y minus 1. A y plus 2, at 1 in the top, 1 in the bottom, and then this, they don't match, right? And so we have for the numerator a y plus 3, and then in the denominator a y minus 3, and a y plus 1. Make my fraction bar a little bit bigger, and there's our answer there. I had to squeeze it in. But our factoring, and hopefully our factoring is getting better and better. And then this one, like someone was nice to me, and they factored these pieces already for me. This is y minus 3 times y minus 4, already factored, y plus 3, already factored, so nice, over 1, times negative 1. And then this, you do need to factor. You need to factor that one, which is, do you guys remember? Y plus 3, y minus 3. It's a difference of squares. I'm hoping that you're getting used to those difference of squares because they have been coming up a lot. And then anything in the numerator will reduce with anything in the denominator. So you could draw this together and say that these are timesing, and I want to make sure that everyone knows that's a time, so put parentheses around it, otherwise it looks like minus 1. And then the y minus 3 will reduce with the y minus 3, and the y plus 3 will reduce with the y plus 3. And in the denominator that leaves 1, so I don't have to write it. And in the numerator that leaves the monomial negative 1 times y minus 4. In the back of the book, I imagine that they write negative of parentheses y minus 4 and don't write the 1. Yes, either way, both, it's all good. So now we have more room, thank goodness. We should have had more room on those. And so we have a division. We have quite a lot of factoring to do with that division. But the first thing I'm going to do to reduce it, the first thing I'm going to do is I'm going to rewrite it so that it's a multiplication. So you're going to flip that second fraction, 27t to the third plus 8 over 8t to the third plus 1. And now I've got to factor all of those pieces. There's 4 of them. And I kind of like to, especially when I have room, and I like to kind of factor these things. And so I kind of make my little work over here. I can even have a little more space, can't I? So I'll go here. And so I like to factor binomials first, but it doesn't matter. And so when I look at that binomial and I'm going to factor that one, I'm like, that one's a friend. This one right here is a difference of squares. And so how that difference of squares factors is how all difference of squares factors. It's 2t times 2t, and a plus and a minus, and 1 times 1. So I'm going to put that right here. 2t plus 1, 2t minus 1. And you only have to go over here on your side piece of paper if it helps you factor it. So you don't have to do that if you're like, I know how that factors. Then I would factor trinomials last probably, and so I would, just because they're not my favorite. And but I really do like cubes, and so that one's a cubed, 27 t to the third plus 8, and you have to know what the bases are in order to get it factored. So, and then you whip out your formula. And so this is 3t, and this is 2. And I like to use my song to factor it, and you factor it however makes you happy. And so if you want to whip out your formula and factor it, this is problem 29, so it's really probably a homework problem. And so if you want to pause the video and try to factor it yourself. And so I'm singing, finger over 3's, write what you see. So I'm writing 3t plus 2. And then I'm singing square, so that's 3t squared is 9t squared. And then the signs are, I'm going to put the sign in after. So multiply those together, so that's 6t, multiply, and square, which is 4. 2 squared is 4. So that's the formula, right? And then the signs go same as you started with, opposite, and always positive, and people say soap. And so I got that factored. So this is 3t squared, 3t. Oh, I had that. 3t plus 2 times 9t squared minus 6t plus 4. And then down here, this one right here is also a cubed, 8t to the third plus 1. And so this is 2t plus 1 to the third, right? And so when you sing your song, whatever you do, to get it factored, this would be 2t plus 1, 4t squared, minus 2t plus 1. And I hope you use your formula or whatever you want to use to do it. So I sing to myself, finger over threes, write what you see, square, multiply, square. So I took this and I squared it, boink. I multiplied them together, boink. I took that one and I squared it, boink. And then the signs were same as I started with, minus, plus, always positive. So that's going to go in here. So this is 2t plus 1 and 4t squared minus 2t plus 1. And then one last thing to factor, and I kind of saved it, is that trinomial there. And so let's see how that will factor. So 6t squared, and this one is definitely a wow, I think. I mean, I've had to really get my factoring going. So it could be 2t times 3t to make the first work. And it could be 1 times 2 to make the last work. And I'm trying to put that together so that I'll get that they'll subtract to be 1. And I kind of noticed that if I can get the 2's together, that'll make 4. And if I get the 3 times 1, that'll make 3. So they'll subtract to be 1. And so let's get those as I said. So 2t and 3t. I want the 2's to multiply together and the 1's there. And let's see, I want the bigger, which is this 4, to be positive and this to be minus. So I want to check it and make sure that I got it correct, because I was thinking about it, right? Trying to put all that FOIL together in my head. So making sure this is 6t squared. So this is my check to make sure. And if you saw the last video, you know that I said, oh, this is how it factors. And then I said, I better check that. And I was sure that I had it factored right. But it turned out that I had made a little bit of a boo-boo, so it was my checking that made it where I, got to have it still right, because I got to change it. And so 2t minus 1 times 3t plus 2. And then because this is times, we can say this all together in one numerator, and anything in the top that's exactly the same as something in the bottom will reduce out. So a 2t plus 1 with a 2t plus 1. A 2t minus 1 with a 2t minus 1. A 3t plus 2 with a 3t plus 2. And leaves those trinomials that are not the same left. And we know those trinomials won't factor because they came from the cube formula. So our factoring definitely needs to get better. We need to exercise our factoring, because boy, they have a lot of factoring in it. Okay, here's the last problem in 7.2, and so you're probably, I hope you're not as weary as I am, but I'm pretty weary today, and so we're gonna try this. So I look there, and you factor whatever you want. It doesn't matter. It's multiply. You got to factor all 4 pieces. And definitely, I don't know. If there were binomials, I would be happier probably, because I like to factor binomials more. But I'm going to have to use grouping to factor that. And that has got a... Oh, I was going to say it had a greatest common factor of 2, but 2 doesn't go into 9. What am I saying? So it doesn't have a greatest common factor, so I am just going to do the grouping so that they have here 2x squared. So this is x plus 1. And then a minus comes down and a 9 is what they have in common when I group them, and that's x plus 2. And those don't match up, and so I think this is the one I have a typo in, because that's not going to factor. And I do remember now, and I thought I changed it. I thought I got rid of it. I thought that I had gotten out the typo, but I haven't. So this is a typo right here. This should have been just x to the third plus 2x squared minus 9x minus 18. If I'm remembering right, I had actually 2 typos in this problem. Nope. Okay, there, I fixed it. So when these weren't the same, I knew there was a problem. And from my memory, the problem was that there was a typo. So now I'll start again here. So they have a common factor of x to the second. So this is x plus 2. Bring down the minus, 9, and x plus 2. And now they are the same. So there is a mistake if they're not the same. And then I have, pulling out the x plus 2 to the front, I have x squared minus 9, which is a difference of squares. And so this one factors as x plus 2 times x plus 3 times x minus 3. So there's our work for factoring one of 4 things. And that one had a typo in it, huh? X plus 2, x plus 3 minus x minus 3 times. So now, should I go factor the other 4 thing, or should I factor one of the trinomials? You can factor any one that you want. So I'm going to factor this one, and I'm saying to myself as I write it down to factor it, any one you want, you factor. Greatest common factor of x. So I'm going to pull it out to the front. So that's x to the third plus 3x squared minus 4x minus 12. And that x is a monomial, and I'm done with it. And so I'm factoring this denominator, and I'm going to put that x over there so I don't lose it. And I'm going to factor this 4-term thing. So this has a common factor of x squared, so x plus 3. And then I'm going to pull out a minus 4, and that's going to be x plus 3. And oh, they're the same. And so we'll pull out the x plus 3, and we get x squared minus 4, and don't forget your little x. And once again, our favorite difference of squares is there, and I think we've seen that difference of squares. At least I have seen it several times today. Hopefully you've seen it several times today too. And so, so we got that thing factored. So it was like wowzer factoring. We have to factor 4 things to get this this problem done, and so your factoring really needs to be exercised. We already have the x here, and then I'm going to put the rest of these things. So x plus 3, x plus 2, x minus 2 times. And then now I'm going to factor the rest of these things. So that trinomial, x cubed plus 5x squared plus 6x, has a greatest common factor of x. And to make, we factored this one today, I think, so far too. To make 5, it's 2 times 3, right? And so x plus 2, x plus 3. And don't forget your little x. And so this becomes x times x plus 2, x plus 3. Then, oh, I got too aggressive. Then x squared minus x minus 6, x times x. 1 and 6, or 2 and 3, right? 2 and 3, and it has to be minus 3 and plus 2. So x plus 2, x minus 3. If you know that your factoring needs exercising, then one thing that you can do is you can go back and practice more problems in factoring, which is on chapter 5. Or you can do these problems because you have to factor 4 things to get one problem done, right? And videos in the book are really good too. And so you can go and check them out too. And so it's a times, and so I can draw the line and see what will cancel out. I like to go left to right, but you could do it however you wanted. So an x plus 2 and an x plus 2. And I'm dividing them out, I get 1. An x plus 3 and an x plus 3. 1 in the top and 1 in the bottom. You cannot reduce out 2 that are in the top. So that wouldn't have worked. You have to do 1 in the top and 1 in the bottom. Because when you divide two things that are equal, you get 1. An x minus 3 divided by an x minus 3 is 1. An x divided by an x, monomial x, is 1. An x plus 2 divided by an x plus 2 is 1. An x plus 3, there isn't one, so this is x plus 3 over x minus 2, and that's our answer there. What a lot of work. And so it's our practicing on our factoring, and this video is much shorter, thank goodness, than the last video. And so I'll have all of this stuff uploaded for you to look at today. And I am hoping that you're having a good Monday. Talk to you later. Bye-bye.